Hi everyone, welcome back to my channel. Today I'm going to teach you how to solve problems on geometric progression. So I have a problem for you. If k plus 1, 2k minus 1, 3k plus 1 are the consecutive term of a GP, find the possible value of the common ratio. We have to find the what? The common what? Ratio, the possible value of the common ratio. Now, here we are given the three consecutive terms here. Now let's say the first term is equals to k plus 1, and the second term, let's say b, is 2k minus 1, and c is equals to 3k plus 1. Now, in finding common ratio in geometric progression, it is always the second term divided by the first term, or the third term divided by the second term, and so on. So our common ratio will be the second term divided by the what? By the first term, or the third term divided by the what? By the second term. Now, finding our common ratio, we now say b, the second term divided by the first term. So we now have 2k minus 1 over the first term, which is k plus 1. Then equate it to the third term, which is 3k plus 1 divided by the second term, which is 2k minus 1. So at this point, we can cross multiply because we need to find the value of k so that we can be able to get our possible value of the common ratio. So if you cross multiply, we have 2k minus 1 into 2k minus 1 is equals to 3k plus 1 into k plus 1. So if you open this bracket, if you expand by opening this bracket, you are going to have 4k squared minus 4k plus 1. If you expand this, equal to, here, if you expand this, 3k times k will be 3k squared. Then we now have plus 4k plus 1 by expansion. So at this point, we can collect like terms by saying 4k squared minus 3k squared minus 4k minus 4k is equals to 1 minus 1. So if you simplify, you have k squared minus 8k is equals to 0. So here you can factorize this. So if you factorize this, we have k into k minus 8 equals to what? 0. Therefore, our k is equals to 0, or k minus 8 is equals to 0, which means that k is equals to what? 8. So k has two values. K is either 0 or 8. Now, let's represent k as 0. Then let's substitute into the values here. So we now have, anywhere we see k, we put 0. So we have k plus 1. So k plus 1 will be 0 plus 1, which is equals to 1. Then 2k minus 1 is equals to 2 into 0 minus 1, which is equals to minus 1. Then 3k plus 1 will be 3 into 0 plus 1 is equals to 1. Therefore, when k is equals to 0, the geometric progressions are 1 minus 1 and 1. So to find the ratio here, we want to know whether the common ratios are the same all true. So if I say minus 1 divided by 1, that is the second term divided by the first term, I'll still have minus 1. If I say the third term divided by the second term, that is 1 divided by minus 1, you still have what? Minus 1, all true. So it means that when k is equal to 0, the common ratio is what? Is minus 1. Okay? Now, let's go further. Now, we represent k to be equal to 8. So, k plus 1 is equals to 8 plus 1, which is equals to what? 9. So, the first term is 9. Let's see the second term. Second term, 2k minus 1 will be equals to 2 into 8 minus 1 will be 15. Then the third term, which is 3k plus 1, will now be 3 into 8 plus 1, which is equals to 25. So the three terms are 9, 15, and 25. Now let's find the common ratio. Let's see if the common ratio is the same or true. Now, and we know that to get the common ratio is the second term divided by the first term, or the third term divided by the second term. So we now have 15 divided by 9. So 15 divided by 9 will give us 5 over 3 here. Then for the third term now, we have 25 divided by 15. If you reduce to the lowest term, you are still going to get 5 over what? Over 3. It means that when k is equals to 8, the common ratios are 5 over 3. The common ratios are what? 5 over 3, all true. Therefore, the possible value of the common ratios, the possible values of the common ratios are minus 1 and what? And 5 over 3. So if you find this video helpful, please follow me by liking and also sharing my videos